This is the walkthrough video for PCTC 2020-2021 round 2 question 7 on the diagonal. So we're going to input a grid and we need to essentially calculate the product of every diagonal pair of numbers and output the greatest product. Now this question is a bit annoying, it's a bit long, but yeah, we'll get to it straight away. So we want to input n and m, so n is going to be int input, then m is going to be the next input, and n and m represent how big our grid is. So which one is the rows? Okay, so it's m rows, and so let's create an empty list call grid, and then for m times, so for I in range m, we want to input the next line. So let's take in the input, then we want to split the input, and we want to convert each of the elements in this splitted list into an integer. So we can do int element for element in this, and let's turn that into a list comprehension like that. And then we've got our list, and now we can just add that list or append that list to the end of our grid. And so now we've built up our grid, and it should now just be a 2D grid of numbers. So now we can do all of the multiplication stuff. So let's keep track of what the highest number that we've stored so far or calculated so far is. I'm just going to set that equal to answer, and initially we're going to set that equal to 0, and we're going to keep increasing this as we come across better answers. So now what we're going to do is I'm going to go through a bit of a brute force solution. The reason we can do a brute force solution is because the maximum our grid is going to be 100 by 100, which isn't actually that big. Like Python can process that amount of numbers really quickly, and so even if our solution is really inefficient, it's still going to be fast enough to get us the points. And I'm not going to waste my time trying to think of a more efficient solution in the competition. I guess it is a good exercise for you to spend your time thinking of a more efficient implementation, but for now I'm not going to bother with that. So I'm going to go through every single element in our grid, and for each of those elements I'm going to go through every single diagonal adjacent, or I'm going to go through every single adjacent diagonal of that element. Multiply the two numbers together, compare that to our answer number, and just do that. So let's go through every single element. So it's going to be for row in range m, and for column in range n. Now I want to, for this element at mn, I want to go through all of the 4 diagonals. So let's do for row delta, and by delta I just mean the change, or like so if we were to go to find an adjacent diagonal of our current element, what we're doing is we're increasing one of the coordinates by 1 and increasing the other one coordinate by 1, or we're decreasing both by 1, or we're increasing one by 1 and decreasing the other one by 1. And that will get us the 4 adjacent diagonals of any given element. And so what row delta is going to be is just going to be the possible changes I can make to row to kind of go through these 4 combinations. But I need to do the same for columns. Let's do column delta in -1 and 1. And essentially what this means is I'm now, at this point in our code on line 15, I'm now going to go through all 4 combinations of -1 and 1 and -1 and 1. And these represent the 4 potential diagonals of our current element. So we can do new row value is going to be equal to row plus row delta. And then we can do exactly the same code but for columns. So new column is going to be equal to column plus column delta. Let's just add a couple of spaces to make it clearer, like that. But of course, you may have noticed an issue, which is, for example, if we're at element 3 up here, well, it doesn't have 4 adjacent diagonals. It only has 2 adjacent diagonals, the 2 and the 1. And so this code is gonna break. It's not gonna work because we're checking for diagonals that don't exist. And so we need to ensure that we check to make sure that our diagonals do exist before doing anything further. So we need to make sure that new row is bigger than or equal to 0, and also smaller than the amount of rows, which is m. And this time we're doing smaller than as opposed to smaller than or equal to, because Python starts indexing at 0. And so the index of the final row isn't actually m, it's m-1. And then let's do the same thing but for columns. So we can do, as long as new column is smaller than n and bigger than or equal to 0, then we are within the right range. So as long as both of these conditions are met, our new coordinate is in the right range. And so that means we can actually do the multiplication. So let's grab our current number. So our current number is going to be grid, row, column from all the way up here. And then the diagonal that we're multiplying it by is going to be equal to grid, new row, oops, wrong brackets, new row and new column. And what we do with this result, well, we want to change the answer to be equal to the maximum of either the answer or this result that we just calculated. And so answer is going to continuously update itself to whatever the biggest number we found so far is. So if the value of this product is smaller than our current answer, we're not going to update answer. But if it's bigger than our current answer, then the max function will just update it for us. And then right at the end of that, we can then just print off answer. And you can see this code is obviously inefficient because we've literally got 4 nested for loops in a row. So we're repeating this like many times, but it should still be just about fast enough to get us all 10 points. Compiler error. Oops, that is a pretty obvious error. Let's fix that. Sorry if you got confused earlier whilst I was typing that out. Yeah, it now works and gets us 10 out of 10.